Okay, question number 1. Students complete the experiment where hot water is placed on one side of a tank and cold water is placed on the other. The divider is lifted and the waters are allowed to mix. What explains the color layers that occur in each diagram? So here we have the hot on the left, the cold on the right, and then when you remove the barrier, the red is on the top, which is the hot, the blue is on the bottom, which is the cold, and eventually we have the purple mixing. So what are the true statements about what happened here? Number 1, hot water is less dense and rises to the top. That's A, 1 only. B, 1 and 2 only. Hot water is less dense and rises to the top, and the thermal energy transfers from hot to cold. C is 2 and 3 only. So thermal energy transfers from hot to cold, and thermal energy transfers from cold to hot. And then D is 3 only, so just the only thing that's true is that thermal energy transfers from cold to hot. Which is your best answer choice? Pick the true statements about what happened here. Okay, number 2. A bottle of warm soda is poured into a glass of ice. Which statement below is most accurate with the transfer of energy between the soda and the ice? So here is energy will transfer both ways. Energy will transfer from the ice to the soda. Energy will transfer from the soda to the ice. Or there is no transfer of energy, D. Which, if we have soda and ice in the same cup, which is going to show the appropriate transfer of energy? Number 3. In the illustration, how will heat energy move? Heat energy will be transferred from the hot plate to the beaker by conduction, the beaker to the hot plate by conduction, the hot plate to the beaker by convection, the beaker to the hot plate by convection. So we have hot plate to beaker or beaker to hot plate, and then we have the conduction or convection options. So what are we looking at here when we're looking at heat transfer? Okay, number 4. 3 metal cubes with different temperatures are placed side by side as shown in the picture provided. Which of the following describes how heat energy will be transferred by conduction? Okay, so we have sample 1, 30 degrees, sample 2, 38 degrees, sample 3, 28 degrees. So here we have the hottest one, the coldest one, and a cool block, something in between. So what I want you to do before you start picking numbers is draw your arrows. Which way will the heat transfer? Okay, so draw your arrows and then pick the numbers here that correspond with the arrows that you drew. All right, so here we have number 1. It will move from sample 1 to sample 2, so it would be an arrow going from here to here. Number 2 is from sample 2, so that's here, to sample 3, so it'll be going from the middle to the right. Number 3 is from sample 2 to 1, so it'll be from the middle to the left. And number 3 is from 3 to 2, so from the outside right into the middle. Okay, so which are the 2 correct directions of energy transfer? Okay, so are we going 1 and 2? So from this one and this one. B is 1 and 3. C is 2 and 3. And D is 3 and 4. Okay, so what you need to do is draw your arrows which 2 arrows you think the direction is going to transfer, and then figure out which of these 2 are the correct ones and circle them, and then pick your answer choice based on what you circled. So take the time to do this so that you don't make a silly mistake, okay? All right, number 5. People get energy from the food that they eat and transform energy as they move. Which energy transformations occur as a student's energy from food is used to rapidly rub the palms of his hands together? So we're starting out here with food. Okay, so let's highlight food. And then we're rubbing the palms together. And then there's something that happens when you rub the palms together. So let's look and see what we have first. Mechanical, chemical, mechanical, or chemical. So which is it? Mechanical or chemical, which is food. And then we're rubbing the palms together. Is that thermal, chemical, or sound? And then what happens when you're rubbing your palms together? Electrical, thermal, sound, or electrical. So A is mechanical to thermal to electrical. B is chemical to mechanical to thermal. C is mechanical to chemical to sound. D is chemical to sound to electrical. So what I would do is I would write it up here and then figure out which one kind of goes with your answer choice. Number 6. Batteries are a special container with 2 sections. Each section holds a different chemical. When a battery is not connected to anything, it stores chemical energy. When a battery is used, so we're talking about when it's connected, the chemical energy is changed into what? Thermal energy, kinetic energy, magnetic energy, electrical energy. What kind of energy is the chemical energy in batteries transformed into? All right, number 7. Which energy transformation example is true? So we're looking for the true statement here. So you want to highlight true. Okay. A plant converts radiant energy into chemical energy through photosynthesis. A solar panel converts radiant energy into electrical energy. A light converts electrical energy into radiant energy, or all of the above. So, do we have plant, chemical, radiant to chemical, solar panel, radiant to electrical, a light, so that's like a light bulb, electrical to radiant, or all of the above? Number 8. The diagram shows a complete circuit with a battery and a buzzer making noise. So this is the buzzer making noise right here. Okay. This circuit works by transforming. So we're going from the battery to the wires to the buzzer. Okay. Chemical to electrical to sound. Chemical to mechanical to sound. Sound to electrical to chemical. Sound to chemical to electrical. So I would write what is the battery first, what are the wires second, and what is the buzzer third. And then see if that matches up to one of your answer choices. Number 9. A student illustrates the following diagram to model the energy transformations that occur when a windmill is used to generate household energy. Name the energy transformations needed to power the toaster with a wind turbine. Okay, so we're looking at the wind turbine. The blades are moving here, and it's converting into what? What does the toaster need to turn on? Okay, so are we looking at mechanical to radiant, electrical to mechanical, mechanical to electrical, or electrical to radiant? So the turbine to the wires is what we're looking at there. Okay, number 10. The picture shows a light bulb attached to a hand generator. What energy transformation occurs as the handle of the generator is turned? So turning the handle for the turn light. So what I would do is I would write it down. I write handle, and then the generator, and then the bulb. So what is that energy transformation? Is it thermal to radiant to light? Radiant to mechanical to electrical? Mechanical to electrical to radiant? Electrical to mechanical to radiant? What is the energy transformation? Okay, number 11. Which energy conversion is taking place in this picture? So we have the sun shining down on the plant. Electrical to mechanical, mechanical to nuclear, thermal to radiant, or radiant to chemical.